I've seen a lot of explainer videos about Tenet, and most of them are awesome, and they take the form of explaining like plot structure and how the different characters are in different places at different times. That's all great. I don't want to retread any of that here. What I have not seen is explanations of the very real physics that is discussed in this movie. I am a high school physics teacher by trade. I spent some time in grad school studying philosophy of physics, free will, time, causality, etc. And there's actually a lot of points in this movie that are, I think, totally worth going through in some detail. This is a physics teacher reacts to the real physics of Tenet in 7 levels of difficulty. Level 1. Tenet is a movie about time travel. They say a bunch of really sciencey things that are mostly correct. Unfortunately, time travel does not exist. However, as we will discuss throughout this video, time dilation exists, annihilation, as they discuss, exists, and indeed, time reversal exists in 2 separate senses in physics. Level 2, no matter how you're time traveling, there's always going to be 2 copies of you in a time travel movie, whatever the mechanic happens to be. In Harry Potter and in Back to the Future, they sort of teleport directly back to the past, and so there's 2 copies of them existing simultaneously for a while. In Tenet, they turn around for a little while, and so there's multiple copies existing. And as we will get to in level 7, when we start talking about the relationship between consciousness and the multiverse, in Avengers Endgame, there's actually multiple copies of people because you're going to another universe and finding sort of another copy of Thanos or another copy of Gamora. That is actually really, really close to being 100% accurate physics. In fact, it's about an area of physics that is not yet fully discovered or discerned. So we'll get there. Okay, level 3. Time reversible events actually do exist in the universe. This might sound pretty wonky, and it is kind of wonky, but it's also incredibly well established. We've known this since 1905 or 1907. I can't remember when the exact year Einstein published this paper. Time dilation and the bendiness of time is an incredibly well established fact within physics. There's explainer videos all over, so I don't want to get too much into detail here. But more or less for this level, time can bend, and the way that time bends can mean that certain people can see certain historical events as happening in different orders. But there are constraints on that have to do with space-like, light-like, time-like vectors in space-time. We will not be able to bend time so much that it rips. To get those 2 copies of ourselves with bending time, we would need to kind of rip time and overlap it with itself, which is not something that special relativity allows. So there is a sense that time reversible events exist within time dilation, but that does not allow time reversed causality, which is what we would need for time travel. If you're interested in some more details of this, I have a lengthy, relatively nerdy essay on my website about this, which I'll link below. Honorable mention at this level. Time dilation exists, time reversible events can exist, but also if you sort of take a second and think about it, which lots of philosophers of physics do. That book Time and Chance by David Albert I took a course about, and it goes into this in lots and lots of details. Brian Greene also mentions this in Fabric of the Cosmos. There is no direction of time baked into the laws of physics. It's unlikely that a coffee cup would sort of assemble itself and bounce back up onto the desk or table where it fell from. But in terms of the laws of physics, even though it's statistically unlikely that would happen, it's not impossible. There's no reason that random events couldn't cause something like this to happen. It's just unlikely that it does. Okay, level 4. This is where things start to get interesting. The movie specifically discusses, they use the word annihilation, and they mention Wheeler and Wheeler's electron, the sort of theory that there's only one electron in the universe, and that all electrons are just one electron moving forward in time, converting to an anti-electron, and then moving backward in time. This was a real theory at a certain point in time in physics. There's lots of reasons why we know that it isn't true. But to sort of explain the foundation of what's happening here, if you haven't heard of an anti-electron, there's matter in the universe and there's antimatter in the universe. Antimatter basically acts exactly like matter. There's no discernible difference between matter and antimatter, except that it has opposite properties in a lot of ways. An anti-electron has the same mass as an electron, but it is positively charged as opposed to negatively charged. they mention while they're orienting the protagonist before he goes out, what happens if you interact with your past self? They say annihilation. That also is referring to a real physics thing. So if you're rolling with Wheeler's theory that an electron is just an anti-electron traveling in the opposite direction in time, which it's not, but we'll talk about other reasons why people sort of thought it was in some other levels, then, and you synthesize this with the fact that antimatter has the exact same properties as regular matter, like it's going to feel gravity, it's going to feel the electric force. You can have an anti-electron and you can have an anti-proton and you can have an anti-neutron. So you can make an anti-atom and you can make anti-water and you could make anti-oxygen even, and you could build an entire planet and ecosystem and world out of antimatter. It would function, as far as we know, exactly the same way as our world does. If you had a self and an anti-self and they met, they would in fact annihilate, which we'll discuss in the next level, but there's a sort of intuitive sense where like, oh, that actually could kind of make sense. And this is where the you need to bring your own oxygen with you thing sort of feels like it could be right. Because as you are bringing your own oxygen with you, you need anti-oxygen, which absolutely could be a thing. Like you could make a bunch of antiprotons, antineutrons, and anti-electrons. The Large Hadron Collider does it. They collect them. Here's a video about it. And you could, in theory, do this. The problem is that annihilation, it wouldn't just happen if you met your past self. It would happen if you ran into any matter at all, right? As soon as the air hit you, you would start exploding in nuclear levels of energy release, and like literally nuclear levels of release. I ran some calculations, like there's the butterfly effect, but like there could be the anti-butterfly effect. A single anti-butterfly that was interacting with the world, if it just sort of popped into existence in the world, would release as much energy as a nuclear bomb, basically immediately. So the protagonist would not be able to walk out of the door if this were the mechanic that were being used. Okay, level 5. Actually, we're going to look at Wheeler again, different experiment. Rather than just thinking of the anti-electron as an electron traveling in the opposite time direction, Wheeler had another famous thought experiment called the Wheeler's delayed choice experiment. If you're familiar with the double slit experiment in quantum theory, it's sort of a canonical explanation to sort of wrap your intuitions around what superposition is. Matter is a wave, and waves can be in more than one place at a time. It's not weird for two people to hear the same person speaking. Like waves can be in more than one place. So if you build two slits in the right configuration and set up all the variables in the right way, then an electron can actually act as a wave and pass through both slits. Now, with many caveats, because there's active scholarly debate about exactly how precisely to explain what I'm about to say. Is it Bell? Is it Everett? Is it the Copenhagen interpretation? There's so many different interpretations of what I'm about to say. But the popular explanation of the double slit experiment is that if you measure at the screen all the way on the other side, then the electron has acted like a wave. It's passed through both slits and it has interfered with itself. Its non-locality has allowed for this wave interference pattern to appear on the end. However, if you measure at the slits, again, measure with air quotes because there's lots of complications in the sort of details of this explanation, then it doesn't act like a wave. It doesn't go through both slits. It sort of decides again in air quotes, to only go through one of the slits, one or the other. This is because, and this is just a total cheat way to get there, but quantum mechanics tells us we quantum quantize things. You can't have half an electron. There is no universe where you can cut an electron in half, even though there are universes where an electron can be in more than one place at the same time. Superposition can exist, but you can't have a half of an electron. It's not allowed. So the electron can only be measured. It can only interact in one slit or the other. So Wheeler says, let's change the scale. Let's say instead of a slit, we use a star. There's a phenomenon called gravitational lensing. If you've seen the black hole photos or even the movie photos of, what's the word, Interstellar, where you see the black hole. This was rendered with like a real physics engine to make it look super accurate. Gravity can bend light. So instead of using an electron, we use a photon, a single particle of light. And Wheeler says, let's take a star that's light years and light years and light years away, and a single photon that travels from one star to the other, and it's going to get to us. Now imagine that electron is going to split, and just think of two paths that it could take around a black hole. Path 1 is the right, path 2 is the left. It's basically the exact same thing as the double slit experiment. There's no detector there, so the photon is going to be in a superposition state. It's going to pass around both sides of the black hole. And when it gets to us, we can set up a measurement device. And this is where the experiment shows us just a freaking weird, super amazing thought, which is we can pick which measurement device we want to put. If we want, we can put like an analog of a screen, in which case it will show us the wave. Or we can aim one telescope at one side of the black hole and one telescope at the other side of a black hole. And if we do this, then it's going to sort of do the same thing as the double slit. It's going to pick a side, and it's going to go one way or the other. So it could have been acting as a wave when it went around the black hole, or it could have been acting as a particle when it went around the black hole. We seemingly get to decide. And this is where Wheeler's insight is because light years is a long, long, long distance, and it takes a long, long time to travel. Years, indeed, hence the name. So seemingly, we get to decide thousands and thousands and thousands of years in the future what an electron did in the past. Did it act as a wave in the past, or did it act as a particle in the past? Wheeler's delayed choice experiment seems to say that we have the ability to like reach back into the indeterminate past and like pick a thing that it could have done. Which, like, holy shit, that's actually kind of cool. And that smells a lot like time travel. Like, whoa, like maybe we could design a machine and we could have, we could store up indeterminate things, and then we could have people from the future contacting people from the past, etc. Like, it is a really, really tempting thought. And if your intuition is pulling you in that direction, it's actually the same thing with quantum entanglement. And this is what cold fusion got wrong. I made a video about cold fusion getting this wrong years ago. I've explained this in other places, so I won't go into it here. But entanglement and wave collapse do not allow for backwards in time causality or for transfer of information faster than light, which end up being sort of the same thing depending on how you're thinking about physics. So all this is to say, Wheeler has given us a way of thinking that we seemingly can reach back into the past. There seemingly are places where we can reach back into the past. But the problem is, in order for this experiment to work, those electrons must have to have touched absolutely nothing all along the way. So it's actually physically possible that this happened. But it doesn't matter. Like, we can't actually cause anything backwards in time, because if those electrons had interacted with something, then the wave function would have collapsed and we wouldn't be able to interact. We wouldn't be able to do anything. And I bring this experiment up because this is in fact like part of how Christopher Nolan is able to get time travel to work in this mechanic. This is, I've heard this referred to as like, it always happened this way, time travel. Like, she sees herself diving off the boat. He fights himself in the past. One of the cardinal rules of how they get this movie to work is that they never allow information to travel backwards in the past. There's a sense then that we can think of the Wheeler's delayed choice experiment as a kind of metaphor for the type of time travel that is happening in this movie. Like, sure, you can, air quotes, reach back into the past, but you're never allowed to actually do anything, or never allowed to actually change anything. Every time they try to change something, like, the thing that always was going to happen is just the thing that happened. And this trust in the mechanics of the universe, like, it's the only way that the physics actually works out in this movie, is that everything happens to work out and no one chooses to blab to their past self about what actually happened in the future. Otherwise, the entire mechanic would fall apart, and they would need it just wouldn't work. In the context of Wheeler's delayed choice experiment, we can reach back into the past, but like, we can't do anything. We just change things we just sort of are completing the process of the past. Incomplete, indeterminate things that haven't been resolved yet get resolved. Cool, that was a lot. Let's keep going. Okay, second and most complicated level here. I want to talk again about this sort of thing that is, how is an electron an anti-electron moving in the opposite direction of time? To get there, you may have heard that quantum mechanics and relativity don't fit together. This is sort of a line that gets repeated to popular audiences. This is true that they don't fit together perfectly, but this hasn't stopped physicists from trying and getting sort of close. If you sort of coarsely chop up special relativity and quantum mechanics and smash them together, you can actually get something that is called the Dirac equation. The Dirac equation is a foundational equation in a field of physics that's called quantum field theory or quantum electrodynamics. It's the thing that you get when you smash together quantum and special relativity. Now, as he was working through these equations, he ended up finding 4 solutions. Physics Girl explains this in a different video. It's sort of like an analog of the quadratic formula. If you get a negative number, you're like, oh, that's not a real thing. It's an imaginary thing, and just toss it out. A lot of times in higher level physics, there's just things that you toss out. So Dirac came across these solutions to his equation, positive energy and negative energy. And he was like, oh, negative energy and negative mass isn't a thing here, so let me just toss those out. It wasn't until later that he discovered that these actually corresponded to antimatter. He kind of stumbled upon antimatter by smashing together these equations, which is just fun. But the reason I bring up quantum field theory is because it gives us a visual way of representing this annihilation thing that we talked about in level 4. Quantized things can only happen in discrete chunks. If you can't have half of an electron, you can't have half of a force on a fundamental level. So think of like a river. You get into a river and it's pushing you downstream. But if you zoom in, or if you are thinking about forces, you might think, oh my gosh, I have like a continuous force that's pushing on you. That's actually not true. If you zoom in, it's bajillions of water molecules that are smashing into you one at a time. Every force in quantum field theory is a one at a time interaction. And this applies to all 4 of the forces. This applies to gravity with gravitons, to strong force with gluons, to the weak force with W and Z particles, and to the electromagnetic force with photons. Photons are the quantized perturbations of the electric field that tell an electron or an anti-electron to move one direction or the other. If particles attract to each other, positive pulls a negative, right? They have to know. There has to be a way that information is transmitted. So a photon is like a little text message that one thing says to another, says, hey, get over here, or go away. Forces are quantized. If you play around with this way of thinking, you actually end up being able to model how forces work with something called Feynman diagrams. You may have seen these. Richard Feynman is a Nobel Prize-winning physicist who famously had them squiggled on his car or something. It's like, no vanity there, bruh. This is scattering, right? This is an electron hitting a photon, and then the electron moving the other direction. Cool. In quantum electrodynamics, we can actually twist this diagram, and we can get a couple of things. If we turn it to the side, we can see annihilation. We can think of an anti-electron and electron slamming into each other and making a gamma ray. If we flip it around, we can get the Casimir effect, where we get energy spontaneously becoming matter and antimatter. This is how black holes end up evaporating. But these Feynman diagrams sort of give us the foundational interactions of the universe. And in this sense, we can think of these as rotatable. And if they are rotatable, then there is another sense in which the electron is kind of like an anti-electron, just moving in the opposite time direction. But like time reversal doesn't allow for reverse causality, and like Wheeler's delayed choice experiment doesn't allow for reverse causality, or doesn't allow for reaching backwards in time, it doesn't really matter. There's no semantic meaning behind you can't make antimatter as a way to communicate things to the past. And if that's confusing, I would encourage you to think about the bullets, like in this scene where Robert Pattinson pulls a bullet out of the wall. Like, who put the bullet there? It would have to have been there already. Same thing with the mirror in the car chase that gets unbroken. Like, they show us that it was broken for the entirety of the car chase. It's sort of meaningless. When in history did it come out of the manufacturing plant, with a broken mirror? In order for things to get undone in the time mechanic of this universe, they have to have been done at some point in the past. ultimately it ultimately doesn't work, even though it's tons of fun. Okay, plan for the final level was to talk about the consciousness and multiverse quotes. The Avengers Endgame multiple realities thing. There is, in fact, an interpretation of quantum theory that's taken seriously by many physicists, particularly at Oxford, called Everett interpretation or many worlds interpretation of quantum theory. We can think of this, like, just real the fast version of this. We can think of this as like... Actually, no, there is no fast version of this. This is complicated stuff. I'm happy to make a 7th video about this. We're already past 20 minutes here, and I want to respect your time and mine. I've discussed consciousness and compatibilism in the Arrival video, and I've discussed backwards in time causality and quantum entanglement in the cold fusion is incorrect video from, like, wow, a super long time ago. So I won't retread that here. So the many worlds interpretation is the theory that there are multiple realities. Every possible reality is real in this theory. As a, for instance, there's a reality where you hit the like button and the subscribe button and the bell, and you shared it with a friend, and you put a comment below for the YouTube algorithm so that my reality of my YouTube channel would not dissipate into a non-local state. Thank you for watching. This gets really, really complicated, and I'm happy to explain it if enough people are interested in it. But I'm Charlie. This is That Makes Sense to Me. Have an awesome night.